The line sizing analysis can be performed within any stream in ProMax just by going into the stream, and on the Analysis tab we can go to Add Analysis, and you'll see here in the list our line sizing analysis. Let's take a look at the different parameters and properties that we have available here. So to start with, we have a horizontal linear pressure drop, and we can put a limit here saying that there's a particular maximum pressure drop that we want, and this analysis will calculate for us what pipe size would give us that pressure drop or would keep us under that maximum. To get started, I'm just going to say we're going to allow a 5-pound drop. You could also type in a maximum velocity if that's a concern, or we can just leave this blank. And I can go ahead and actually just click Solve now, and we'll look at the results and talk about those. You can see that from this pressure drop, ProMax has calculated the pipe size we would need to stay under 5 pounds. If I go a little further down, you'll see our total linear pressure drop in this case is 4.89 pounds per 100 feet. And so this doesn't end up exactly at 5 pounds. You would need like a 2.9 inch pipe size, something like that, and of course you're going to buy them on your actual sizes. And so this is saying that a 3-inch pipe would give you a pressure underneath our 5-pound limit. Now, a few of the other properties available to us here, we can change the pipe schedule that we want to use. We can also change the pipe roughness and the angle of inclination, and so you can do this for vertical pipes or inclined pipes. We'll see as I scroll down that it calculates our gas velocity, liquid velocity, and mixture velocity. And the mixture velocity is just the gas velocity plus the liquid velocity, and in this case we're 100% gas, but you can have a mixture in this analysis and that works just fine. Now if we wanted to put a limit on our velocity, let's say that for some reason we wanted to stay below 70 feet per second, we could come up here and type in a maximum velocity, and when I click Solve again, we see that we get a different pipe size. Our pressure drop is much lower now, but now our velocities are also below our limit. And you can even see here in the warning that it explains that in this case it's that velocity specification that's controlling our pipe size. If we continue on down, we can also see that with our flow regime, if we do have a mixture, ProMax will calculate the liquid holdup for that mixture. We also get into erosional velocities. By default, ProMax uses this API RP14E equation to calculate the erosional velocity based on this constant C value we can give it. So you see that erosional velocity is calculated here. If you have a very sandy fluid, there's another equation that's used that utilizes this sand fluid mass flow ratio. Usually 5 ppm is the default here. If you wanted to use that equation, you could put in that number, or if you knew the actual ratio, you could put that here, and then ProMax would use that second equation for its calculations. At the very bottom of this analysis, we also have the ability to calculate a maximum allowable working pressure. That's going to be based on first our material of construction. So if I go here to the material of construction and click on this arrow, that's going to give me a list of the materials that I have to select from. And so you can see right now I'm on my steel options. I could choose any particular carbon steel that I expect to use. Looking back here at the groupings, we have a large variety of options from aluminum down to our steels and even thermoplastic options. And so you can choose the option that fits your plans. I'm going to just choose a carbon steel and click OK. We're also going to type in a corrosion allowance, and we can define which pressure code we want to use. I'll just leave it as the default, but there are your options there. And then with the factors, we can click Solve, and ProMax will calculate our maximum allowable working pressure. And so that's another part that's included in this analysis. Now, in many cases, you may be wanting to size all the lines in your process. So if we go back to the flow sheet, you may want to do that line sizing analysis for each stream, and you might want to try vertical pipes versus horizontal, and just a large amount of calculations. So I want to mention that we have a report that's designed specifically to do line sizing for an entire project. If I come up here to the Reports button, if you were to choose templates, one of the template options is a line sizing report, and when you select that report, it looks like this. Let me just bring up a completed report. But what we have here is each stream in its own column, and then that line sizing calculations have been performed for a horizontal pipe, so 0 inclination angle, vertical upward flow, vertical downward flow, and even inclined flow at 45 degrees. And so this report by default will do this line sizing for every stream at each of these different cases, and so that can be a really useful report to go along with those analysis options.